Hello, it's Miss Coletta here, and today I would like to show you how to measure the magnitude and heading of a resultant vector. So just to explain what a resultant vector is, I'm going to draw a very rough sketch for us. A resultant vector takes any two vectors and connects them like two legs of a trip. So if my first vector looks like this, and then my second vector starts where the first vector led off and goes like this, then my resultant vector shows me where I end up as a result of those two different vectors' movements. So here I would just connect the very beginning of my trip, which is right here, to the very end of my trip. And you can imagine these as two legs of a trip. You've gone on a certain heading with a certain magnitude, and now you're connecting the beginning point to the end point with its own vector. This vector is called the resultant vector because it just shows you where you end up as a result of the other two vectors. So now let's take a look at our specific example. Our example here wants us to find the resultant vector a plus b if a is 2 centimeters with a 120-degree heading and b is 5 centimeters with a 40-degree heading. So just like any vector scenario, I start off drawing a vector, and I'll start by drawing vector A since that's the first one that I'm supposed to use. So here what I'll do is I will put a dot for the beginning of my vector, and I will draw myself a north line. And then I know I need to measure the angle. So I bring in my protractor, and I line it up with my dot, and I line 0 up with my north line. And then I'm ready to measure the angle. And here you can see that my heading is 120 degrees. So from the north line, I just look to see here. And you'll notice here this protractor is a little bit different than the one we use. Once it gets up to 90, it starts counting down. But we know that this would continue to go up. So this would be 90, and then 100, and so on. So what I'm going to go do here is just kind of count. This is 90 degrees, then 100, then 110, and then this one that's marked 60 for us would be 120 because we've gone 90 and then another 30. So I'm just going to put a little mark there. And I know I need to line a ruler up here and measure only 2 centimeters out between this dot and this tick mark that shows me the angle of 120 degrees. So I'm going to go ahead and get my ruler and make sure I measure off 2 centimeters. Okay, so you can see here I've lined up my ruler, and now I need to mark off 2 centimeters. So 2 centimeters is right there, and I'm just going to draw my vector along the ruler, ending at 2 centimeters. Now, we've taken care of vector A. The next step is to take care of vector B. So we know that we're adding vector B. And here, if we're adding it, we have to imagine that we've gone a part of the way on our trip, say sailing a boat, and we've reached this point at the end of the arrowhead. Then from there, we are going to follow whatever vector B tells us to do. We're going to add that onto our trip. So that means that vector B starts at the very end of the arrow of vector A. And before I move on, I should label everything I know about vector A. So this angle was 120 degrees. This magnitude was 2 centimeters. And I'm going to put a little vector A label so that I know that's vector A. Now I'm ready for vector B. Okay, so I put my dot right at the tip of vector A because I know I'm adding it on. Now, I have to draw a new north line for vector B, because if I was just going to draw vector B by itself, I would always draw the north line from that starting dot. So I draw my new north line, and then I'm ready to bring in my protractor again. And I apologize in advance because this is going to get a little messy with my picture since I have one protractor already on the screen, so we'll have to be a little careful when we're measuring, but hopefully it won't be too bad. Okay, so again, I want to line up my protractor with my dot, and I need to measure off the angle, and in this case I want an angle of 40 degrees. So I'm going to go onto the edge of my protractor and put a little tick mark right there at 40 degrees. And then we know that we want that to be 5 centimeters long. So I need to bring in my ruler and measure off 5 centimeters. And again, might get a little bit messy, but at the very end I'll copy my picture onto another screen so that it doesn't look quite so messy. Okay, so I've lined up my ruler along with my angle of 40 degrees, and I know I want this to be 5 centimeters long. So I draw my vector here, and I should label this 40 degrees, 5 centimeters, and this is vector B. And at this point I'm going to copy my vectors without these protractors and rulers in the way onto another screen so that we can finish the problem. Okay, much better to look at. So now what I need to do is just draw my final vector, which would be vector A plus B, the resultant vector. Okay, so what I'm going to do is I'm going to look here, and if you notice, this is my very initial starting point here where vector A began. That was the beginning of the trip. So I draw a new north line right on top of vector A. That's going to mark off the starting point for my resultant vector. And then my resultant vector connects from the very beginning of the trip to the very end of the trip. So I'm going to draw my vector so that it lines up just with the end of the arrowhead on vector B. And I'm going to mark off that vector, and I'm going to label it A plus B, because that's the two vectors I added together to get this vector. Now what I need to do is I need to measure two things about this vector. I need to measure the heading, which would be this angle right in here from the north line down to that vector, and I need to measure the magnitude or the length of that vector. So I'll bring in my protractor first and rotate it and line it up with my center dot, and I will mark off what the angle is. Now if you look here on the protractor, it looks like my angle hits at about 64 or 65 degrees. So I'm going to say 64 because it looks like it's right on the edge of the 64 there. So I'm going to mark off my heading, 64 degrees. And then I need to measure the length. And again, our picture's going to get a little messy while I bring in the ruler, but at the very end I'll copy it to a clean screen so you can see the final product. And now, once I have my ruler in here, I can figure out the length. So you can see that I've lined my ruler up starting at the dot and stretching along the arrow, and it looks like I hit at about 5.7 centimeters. So I'm going to label this 5.7 centimeters. And whenever you do a problem like this that asks you to find the magnitude in the heading, you should write it off somewhere to the side. So I'm going to write vector A plus B equals, and I write my magnitude and my heading. So it's 5.7 centimeters on a heading of 64 degrees. And notice I'm writing the word heading here because, as I've told you before, there are other ways we could measure our angles, and we want to be specific here. And I'm just going to copy a clean copy of the picture so that we have our final answer. And there you go. This would be the work required to show that you measured the magnitude and the heading of the resultant vector. You need the first vector, vector A, the second vector, vector B, connected to the head of the end of vector A, and then you need the resultant vector going from the very beginning of the first vector to the very end of the last vector. Once you've measured everything off, then your final answer is just the magnitude and the heading accompanied by the diagram that you used. And we're done. Thank you so much for joining me on learning how to add vectors and measure the magnitude and the heading.